All right, friends, we're going to pick up where we left off yesterday. We're going to review just a little bit. Today, we're going to use exponents to denote the powers of 10. So that I can apply it to metric measurements, I will know that I have it when I can accurately solve these two equations. Same learning target we had on Friday. So, yeah, we're going to, whoops, sorry, I forget which way I have to go to make these move. There we go. All right. How many centimeters equal 2 meters? Now on Friday we talked about horse to fly, multiply, or fly to horse, divide, of course, right? We did the little song to the Spider-Man theme. So the question is, how many centimeters are equal to 2 meters? So we are starting with, I'll grab my pen, we are starting with 2 meters, right? So we're going from horse because 2 meters, see this is 2 meter sticks, just like your paper meter sticks, right? And we're going to say equals how many centimeters, okay? So we are going from a horse, which is big, to fly, which is smaller, right? And centi means 100, remember? So if we're going to go from horse to fly, we're going to multiply. We're going to multiply by 100. So we say 2 times 100 equals 200 centimeters. Yep. Now you could take your 2 meter sticks if you wanted to. You could take one and count all the centimeters. You could take a second one and count all the centimeters. Guess what? You get 200 centimeters. Oops. Working in a different program, so I lose track of where I'm supposed to be. All right, so meters 2, centimeters, because centimeters equals 100, right? Okay, millimeters, milli means 1,000. So there's in 2 meters, same 2 meter sticks, right? It's the same thing. It equals 200 centimeters, which equals 200 millimeters. To tell me a multiplication equation multiplying by 2 to get to 200, right? 2 times 100 equals 200, right? 100, 200. Got it? Good. Okay. 2 times 100. Now, we're going to rename 100 using an exponent. Remember yesterday or Friday we talked about exponents are that tiny little number, and it tells us how many times we multiply by 10 to get to 100. We know that 100 is 10 times 10, isn't it? That's 10 times, 10, right, equals 100. My numbers tend to slope when I'm drawing them with my mouse. Which also equals, right, I have 2 10s, I have 2 zeros, so it's 10 to the second power. 10 to the second power, okay? All right. We're going to see that on this slide. Yep, 10 times 2 to the second power. Now, you don't have a partner at home, but you can do this with me. How many centimeters are equal to 1.37 meters? So I'm starting with meters, right? So I'm going from big to small or small to big. 1.37 meters equal to how many centimeters? We're going from horse, which is meters, to fly, centimeters. And we know that centimeters, that means 100, right? So we're going to multiply times 100. 1.37 times 100 to get to our centimeters, right? Now, there's 2 zeros, so our number is going to take 2 hops and it's going to go this way, right? So think about it like this. If we said 1 times 100, what would we have? 100. So we're saying 1 and some more times 100 is going to be the same thing. This number is going to take 2 hops this way, becomes 1, then everything follows along behind it. 3, 7, right? Everything followed along by 2 steps. The 3 moved over 2 steps, 7 moved over 2 steps. Our decimal lands right there, okay? 137 centimeters. Now you could see that on your meter strip if you wanted to, right? You could take your meter strip and you could, 1 meter is 100 centimeters, right? And then 37 hundredths of that is a centimeter. All right, so now we're going to solve it using an exponent. How? Let's take a look. Go back. It's the same equation, right? 1.37 times what? Times 100, but we can write that as a power of 10, 10 to the second power. And the 2 tells us that this is going to move 2 hops, right? 10 times 10. Okay. All right. What must we do to the number of meters to rename them as centimeters? We're not changing how far we've moved. We've still only gone 2 meters, 2 meter sticks. But we can call it 2 centimeters or 200 centimeters or 2,000 millimeters. It doesn't change the width or the space we jumped. Same thing here. 1 meter is the same as 137 centimeters. It's the same as 1,370 millimeters. It doesn't change the amount of space we're covering, right? Okay. How many centimeters are equal to 2.6 meters? So we're going to take our meter strip. There's 1 meter, 2 meters, and a little bit more, right? This is a meter. This is a meter, right? And this is 0.6 of the meter, right? How many centimeters would be in this 2.6 meters? And again, are we going from horse to fly or fly to horse? We're going from horse meters to centimeters that are itty bitty, right? They're about the width of a marker. Centimeters are about the width of a small whiteboard marker, not even my big whiteboard markers, okay? So centi means 100. We're going to multiply, and we're going to multiply by 100 because we're going from horse to fly, multiply by 100. So 2.6 meters times, now I'm going to write this as an exponent, okay? 10 to the second power. That means 100. 10 times 10 is 100, okay? So this 2, if I said 2 times 100, what would I get? 200. So the 2 has to go in the hundreds place. Then the 6 goes right behind it. Oh, but I don't have 200 yet. I need to add that 0. It's 260 centimeters. Here we go. Okay. Now, this one was kind of tricky. Okay. If we take 2 meters times 100, we've gone 2,000 meters, right? 2 times 10 to the third equals 2,000. 2 meters also equals 2,000 millimeters. In this one, we went from a few steps across our classroom to basically walking from Parkside to about State Street. Maybe not quite that far, but close enough. Or maybe to the Murray Library from Parkside, okay? 2,000 meters, okay? Here, we're simply changing how we're calling or how we're naming the distance. It's the same distance. We're going to take 3, 4, 5 steps across the classroom, and we're going to have moved 2 meters. We will also have moved 2,000 millimeters, right? That difference is really important to understand. But in this case, we've gone much further distance, but in this case, we haven't changed the distance at all. We're converting units, we're not making them any bigger, okay? problem A is not renaming or converting, but multiplying 2 meters by 10 to the third. So the answer is 2,000 meters. Problem B is renaming by multiplying by 1,000 by 2, because each meter has 1,000 millimeters in it. So after we multiply, we can name the unit. It's the exact same measurement, however, exact same distance as if, we just are calling it by a little bit different name. Okay? So to rename large units as small units, horse to fly, multiply. Horse to fly, multiply. Okay? It doesn't give us any more distance. It doesn't make 2 meters into more meters. It just renames the 2 meters as 2,000 millimeters, right? The length stays the same. It's really important we understand this because we're making more units by simply decomposing or cutting apart our meter and renaming it with smaller meters, smaller units. We're not making copies of that meter. All right. And of course, going the other way, fly to horse, divide, of course. So if we're going to go from centimeters to meters, remember centi means 100, but now we're going from fly to horse, so we're going to divide by 100, okay? And with millimeters, we're going to divide by 1,000, or 10 to the third power, because milli means 1,000, right? Millimeter is 1/1000th of a meter. So let's look at these two problems, okay? In this case, we have 2,000 millimeters and we're dividing it by 1,000 and we're left with 2 millimeters. In problem D, it's all about what we label it, right? Millimeters, meters. These are the same. These are exactly the same. Same length, same distance we'd have to walk, which isn't very far. In this case, we're going from 2,000 millimeters, so 2 meters, which is a little more than 6 feet, down to 2 millimeters, teeny tiny, 2 millimeters. Okay? In this case, we simply renamed our units. In this case, we took them apart and got rid of a bunch. All right, 1,000 millimeters equals a meter. 2,000 millimeters equals 2 meters. So we're dividing the number of millimeters. It's as if we had 2,000 cookies, and I'm going to divide them amongst 1,000 people. Each one would get 2 cookies. Okay? In this case, I'm taking my 2,000 cookies, and I'm dividing them into each one into 1,000 little bits, which leaves me with 2. That analogy falls apart. Sorry, friends. But if I divide them into 1,000 little bits, I'm still keeping all the bits together to get my 2 cookies. Division renamed the 2,000 millimeters as 2 meters. How many groups of 1,000 are in 2,000? 2. 1,000 millimeters got grouped together as 1 meter, so we divide or make groups as 1,000, right? It's just like if we were dividing up cookies. It's just bigger numbers. Right? A ribbon measures 4.5 meters. Meters, and we want to convert it to centimeters. Now, are we going from horse to fly or fly to horse? We're going from horse to fly, so we're going to multiply. And centi tells us we're going to multiply by 100. 4.5 times 100. Right? If I said 4 times 100, it would be 400. So this is going to take 2 hops. The 4 goes into the hundreds place. Right? The 5 follows along. But I don't have 400 yet. Now when I add a 0, now it's 400. And you can do all of these on the templates as well. Problem 4. A wire measures 67 millimeters. Convert its length to meters. So now we're at 67 millimeters, and we want to convert that to meters. Now we're going from fly, little itty bitty teeny tiny thing, to meters. So we're going to go from fly to horse, divide, of course. And with millimeters, milli means 1,000. So we're going to divide by 1,000. 67 divided by 1,000. 3 zeros. So this 6, right? Here's our decimal. It's going to take 3 hops. Change the color of my pen so you can watch me do this a little better. Okay. So it goes to the ones place. It then goes to the tenths place. It goes to the hundredths place, right? Lands here, 6. Decimals over here, okay? 7 follows it, but I have an empty spot here, don't I? I have an empty spot. It goes to the ones place, tenths place. Yep, I have one empty spot there. 67 thousandths of a meter is my answer, okay? And if I wanted to write this in exponential form, this would be 10 to the third. All right, how can 4.5 and 450 represent the same amount? Well, it's the same length of ribbon. We're just renaming it, right? Same length of wire. We're just renaming what we call it. Okay? Now, here's the problem set. Problem set is in class kick. To write these equations, it's kind of complicated to type them in. I want to see all of this, okay, correct. So work on that until you get it correct. If you can figure out how to write these equations, this one, because there's lots of different keyboard shortcuts, and it tells you in the class kick how to do that, but it's a little bit time consuming. So don't get too hung up here if you're getting the correct answers here. And you'll know that you're getting the correct answers because when you fill in a box, it will have the, you'll get a green check mark. Your job is to do all of problem set 1. So that's A through G, right? Oops. Oops. All of problem set problem 1, all of problem 2, and then there's number 6. So that's your job. Like I say, don't get too caught up with this over here. Keep in mind, centi means, and on problem 2, milli means, right? So keep those things in mind, and I think you're going to do just fine. I will get the exit ticket loaded. We tried to do it in a different program today, and it didn't work. The technology. Keep saying this. Some of it's coming along really, really well, and some of it is not. So just bear with us as we work through these things. All right. So good luck, and I will see you later.